All right, welcome to chapter 14.1, the chi or chi-square test for goodness of fit. It doesn't matter which way you say it. You will notice that it is not 14.2, it is chapter 14.1. So please correct that if it has not already been corrected. All right, so we're still going to go through the hypothesis test. We're going to go through all of the things that we did before. We're going to go ahead and do the hypothesis, the alternative hypothesis, the conditions, the calculations, and then our conclusion. Now, goodness of fit can often be abbreviated GOF, okay? The chi-square test for goodness of fit. Okay, a goodness of fit test is used to help to determine whether a population has a certain hypothesized distribution, expressed as proportions of individuals in the population, falling into two various outcome categories. Okay, we're not looking at means, okay, either one mean or two means. We're not looking at just a single proportion or two proportions. We're looking at more than two proportions, okay? So we will not be using the z-test. Okay, we will not be using the z-test. We will not be using the t-test. Okay, we have a new test, which is the chi-squared test for goodness of fit, and we use what looks like x squared. That is the symbol they use for the chi-square test. Now, in this test, when we look at this data, we're either going to have one row with multiple columns, or we're going to have one column with multiple rows. Either way, we're going to either have one row or one column. Okay, that is very important. Either one row or one column, because that goes with the goodness of fit. If there's more than one row and more than one column, then it's just called a chi-square test, and that's different. That's going to be in chapter 14.2. So we're going to see things in this chapter that are going to be tweaked slightly when we get to the next chapter. All right, so the hypothesis. The actual population proportions are equal to the hypothesized proportion. Okay, first we're going to calculate the chi-square test statistic. So this one's a little bit backwards. We come up with our hypothesis and our alternative, and then we actually do the calculations first, because we can't do the conditions until we have actually calculated some of our information. So x squared equals the sum of the observed count minus the expected count squared. Okay, divided by the expected count. Now we actually have to figure all of those out. And again, I'm going to show you with the calculator how we can do that. We can abbreviate this simply with O for observed minus E for expected squared all over expected. All right, we're also going to deal with degrees of freedom. Okay, so K is how many observations there are. Notice we're not using the letter N, we're using the letter K. So we're still going to take one away for our degrees of freedom. Now, we're using a different table for this one. Okay, we're using this table. Okay, you will notice, ladies and gentlemen, that the normal curve is actually not really all that normal for this test. It is actually skewed to the right. Okay, and it's always kind of skewed to the right for the chi-square test. If you read the chapter in the book, you can see some other pictures that show you how it is skewed with the different degrees of freedom. Okay, so degrees of freedom is on our left. So just like before, if K is 5, then our degrees of freedom will be 4. Okay, you will notice these numbers are very large within the table. Okay, this table is only set up for the chi-square. Now, I'll show you or demonstrate with one example how we can find some of the information in the table, but I'm going to primarily focus in on using the calculator instead of going to the table. All right, back to the notes. Now, the condition, well, the p-value, okay, the p-value, to find that, if we find what our chi-square is, we can then type in some values on our calculator, and just like before, with the mean and the proportion, we can either use the normal CDF or we can use the TCDF, but for chi-square, it has its own place to go to, and I will show you where that is. All right, the conditions. You may use this test with critical values for the chi-square distribution when all individual expected counts are at least 1 and no more than 20% of the counts are less than 5. Okay, so if everything's above 5, no problem. Okay, but if something is not more than 5, only 20% of that can be below 5. Okay, so think about it. If I have 5 values, 20% would be 1 value. So 1 value out of the 5 values could be less than 5. If I have 10 values, then 2 values could be less than 5. But they all must be at least 1. All right? The chi-square distribution are a family of distributions that take only positive values and are skewed to the right, as I mentioned when we looked at the table. Again, a specific chi-square distribution is specified by one parameter called the degrees of freedom. Now, if you have a newer calculator, you will have an advantage for this. If you don't have a newer calculator, I will show you how we can use list 1 and list 2 and list 3 to help figure out the chi-square, the value that we're going to use. Okay, so I'm going to demonstrate that first, and then those of you that have a newer calculator, I will go ahead and demonstrate that. All right, let's go to the Inference Toolbox. Okay, again, this is for chapter 14.1. All right, so the hypothesized value. Identify the population of interest and the parameter you want to draw conclusions about. State your hypotheses. State them in sentence form. Okay, so our hypothesized value. Now, again, it needs to be in words. So whatever we're looking for, and then somewhere within that sentence, we need to say something like equally likely, or we might need to say something will have the same distribution. So our hypothesis is that something is going to be the same, or something is going to be equal. That means our alternative hypothesis, again in words, will either not be equally likely, or the distribution is different. Dot, 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 dot. Okay, I will go through 2 examples. That might make a little more sense after the 2 examples. All right, conditions. Well, we just went over the conditions on the other page. Okay. So again, we want it to be an SRS. Okay, now here it says all expected counts are 5 or greater. Okay, that's what we're hoping for. But remember, okay, they all need, if you look at the other sheet, they all need to be at least 1 and no more than 20% can be less than 5. All right, calculations. So again, we're going to do the chi-square, which is observed minus expected squared divided by expected. Once we have that figured out, we will then be able to find our p-value. Okay? And again, I'm going to show you on the calculator what you can do for the p-value. All right? And then our interpretation, interpret the p-value or make a decision on the hypothesis. Don't forget the 3 C's, conclusion, connection, and context. That part is not the same. So it's slightly different with the hypothesis, putting in the words, the conditions. These are the conditions for the chi-square, and then figuring out our calculations. We will continue with the examples on part 2.